Hi. In our last lecture in this unit, what we're going to do is we're going to look at something called the value of information. Now, in the previous lecture, we looked at how to make decisions under uncertainty. And by definition, right, you don't know what's going to happen. That's what uncertainty means. Well, you can ask a question in those models, what if I did know the answer? How much would the information be worth to you? And here's one of the real benefits of having this formal model, this formal structure. So if you've got this formal structure, we can actually figure it out. We can actually solve for what the value of that information is. So let me give an example. Think of the game roulette. So roulette has a wheel, and the United States roulette wheel has 38 different numbers you can bet on, right? The numbers 1 through 36 plus 2 other spots. So there's 38 things you can bet on. And if you put up, if this is a classical probability thing, right? If I guess a particular number, the odds of me winning would be 1 out of 38. So what I could do is I could say, what's the value of information? What if somebody knew what was going to happen? There's 2 different questions we could ask. The first question we could ask is, what if the person would tell me, what if I said, look, I always bet on number 17. 17 is my lucky number. What are the odds that 17 wins? Someone says, well, I can tell you that before the wheel goes. Is it worth it for you? What's the value of that information? Well, first off, your odds are you're going to lose at roulette, right? And so if you're going to lose, you wouldn't want to bet anything. So if you didn't have the information, you'd bet nothing. So your payoff is 0. But what's the information worth to you? Well, suppose if they tell you this, you could win $100. Well, then you think, well, boy, that information's great. That's worth $100 to me. Well, that's not quite right, because it's only worth $100 if he tells you that your number is going to come up. So if he says it's not going to be 17, well, then you don't bet. But if he tells you it is going to be 17, you do bet and you win, and you're only going to win 1/38 of the time. So the value of that information would be 100 divided by 38. Now, alternatively, suppose the person said, I can tell you the winning number. And suppose the most you're allowed to win is $100 per round. But this person says, look, I can tell you the winning number. Well, if they can tell you the winning number, you're going to win $100. So if you're going to win $100, then the value of that information is $100. So the value of the winning number would be $100. The value of knowing whether your number wins would be $100 divided by 38. Okay, so that's the idea. But now we want to apply this in a context that's a little more complicated, where we do our decision trees and that sort of thing. So let's do an example. Let's suppose you're thinking about buying a car. And you can buy the car now, but you're worried that there's going to be a cashback program. So you've heard some rumors that in a month there's going to be a cashback program. And this cashback program is going to give $1,000 cash back. And based on, let's suppose you've done a frequency analysis of the number of years in the past they've had a cashback program, and you figure there's a 40% chance they're going to have a cashback program. So what you could do is you could rent a car for $500 right now, and then wait and hope there's a cashback option. So what we want to do is we want to figure out, what would it be worth to you if someone could tell you? So suppose you knew someone at the auto company, and they said, well, I can tell you whether they're having a cashback program or not, but it's going to cost you, right? So what would that information be worth? How much would you pay to know if there's going to be a cashback program? That's what we want to figure out. Okay, first off, I want to say that's not an easy question, right? So if I said, what's it worth to you? I don't know, $50, $100, $200, $300, who knows, right? That's what we want to try and figure out. So to figure out the value of that information, we just have to do 3 things. First, we're going to calculate the value without the information. So we're going to say, suppose I just have to make my choice. What's my optimal choice? How do I come out? Second, I calculate the value if I had the information. So if I knew what was going to happen, what would I do? What would my net value be? And then third, I just take the difference. I take the value with the information minus the value without the information, and that tells me sort of what the information was worth. Totally straightforward, easy to do, provided, again, we use this decision tree model. Without the decision tree model, it's going to be pretty difficult. So here's my choice. Do I rent or do I buy? Right? Now, if I buy, then, I'm just out nothing, right? There's just my net values. We just have this my baseline value. If I rent, then there can be the cashback program, right? Or there cannot be the cashback program. Okay, so let's make this more formal, right? So if I buy, I get nothing. If I rent, then, and there's no cashback program, then I basically wasted $500 renting for the month. But if there is a cashback program, I net $500. Why $500? Because remember, there was $1,000, right, cash back, minus the $500 to rent, so that's $500. Now, what was the probability of the cashback program? It was 40%. And what was the probability of there not being a cashback program? That's 60%. So now I got to figure out, okay, should I rent or not? Well, look, I've got 40% times 500 and 60%, make a little point there, times minus 500. So if I multiply that out, 0.4 times 500, which is 200, plus 0.6 times minus 500, which is minus 300, I get minus 100. So what I get is, if I were to rent, I'm out $100. So if I can basically draw my tree, it's pretty straightforward. If I buy, I get 0, and if I rent, I'm out $100. So what I should do is I should buy. So without the information, right, let's think about what I do. Without the information, I should just buy, and I'm sort of at this net 0 case. So that's what I've done. I've calculated the value without the information. Now what I want to do is calculate the value with the information. Suppose I knew what was going to happen. So now I can just draw another tree. And this tree is going to look different than the first tree, because here's what's going to happen. First, this chance node is going to be revealed to me. Somebody's going to tell me, is there a cashback program or not? And 40% of the time they're going to tell me yes, there is. 60% of the time they're going to tell me no, there's not. Well, let's think about what's going to happen. If they tell me there's a cashback program, then I'm going to rent and get $500. If they tell me there's not going to be a cashback program, then I'll buy, and I'm just in the same situation I was before. So if I have the information first, then I've got easy choices once it's my choice, because look, once the information is revealed, there's no longer any uncertainty. So with the information, I'm no longer making a choice under uncertainty. So clearly, if there's a cashback program, I rent, and I'm up $500. And if there's not a cashback program, I buy, and I'm back to this baseline case of 0. So what's the value if I knew this information first? Well, 40% of the time, I get $500, and 60% of the time I get nothing, so it's worth $200. So with the information, my expected value is $200. So let's go back. Calculate the value without the information, 0. Calculate the value with the information, $200. Calculate the difference, $200. Right, so you make this more formal. With the information, $200. Without the information, nothing. So therefore, the value of that information is $200. In this case, right, this was a fairly simple one. But we could go back to both of the two examples we did in the last lecture, the one about buying the train ticket and the one about writing the essay. And we could say, suppose we knew what was going to happen. Suppose we knew if we were going to make the train, and suppose we knew if we were going to win that scholarship. We could ask, what's the value of that information? How much would it be worth to us to know what was going to happen? And again, you just do the same thing, right? We'd follow that same technique. Solve it under uncertainty without the information. Solve it as though you knew the answer. And then just take the difference between those two values. So what have we learned here? We've learned that we can take a model developed for one purpose, right? This decision tree model. We developed that to figure out how to make decisions under uncertainty. And we can repurpose it. We can use it to figure out the value of information. We can figure out how much would it be worth for us to know what the future is going to unfold, how the future is going to unfold. And it's really straightforward to do, right? It was a three-step process. First, we figure out what we do without information. Then we figure out what we do with the information. And then we can see how much better off we are with the information. And that tells us the value of the information. And that would be, in many cases, be a very hard thing to do in our head. But with this simple tree model, it's really straightforward and easy to do. So again, we see the power of models to help us make better choices. Thanks.